Hello everyone, welcome back to Physics HQ. This is Professor Sandeep, your tutor for the class 12 series. Continuing with the lecture series of solving MCQs and sums of class 12 physics, today we will be covering textbook unsolved sums of chapter 13 AC circuits. This is the second part of the sum solving. We have already covered the first part and we have also covered the MCQs of this chapter from the textbook. Please check out those videos as well. So let us continue with the first sum for this video. A capacitor of 100 microfarad, coil of resistance 50 ohm and an inductance 0.5 Henry are connected in series with 110 volt 50 Hz source. Calculate the RMS value of current in the circuit. So capacitor is 100 micro, which is 10 raised to minus 6 farad, or we can write it as 10 raised to minus 4 farad. Resistance is 50 ohm. Inductance is 0.5 Henry. Frequency of the source is 50 Hz. ERMS is given as 110 volt. We have to find what is IRMS. This will be given by the formula ERMS by Z, and Z is given by the formula R square plus XL minus XC square, the whole under root. Let us find out the values of XL and XC first. XL is given by the formula 2 pi FL. This is equal to 2 into 3.142 into 50 into inductance is 0.5. So this 2 and 0.5 will become 1. 50 into 3.142 will give us 157.1 ohm. XC is given by 1 upon 2 pi FC. This is equal to 1 upon 2 into 3.142 into 50 into 10 raised to minus 4. 50 into 2 will be 100 and we will be left with 1 upon 3.142 into 10 raised to minus 2. Now we can take reciprocal from the logbook over here and we'll get 0.3183 into this 10 raised to minus 2 from denominator. It will become 10 raised to 2 in the numerator. So finally we got XC is equal to 31.83 ohm. Now we can find out Z easily. Z is equal to root of 50 square plus XL is 157.1, XC is 31.83 the whole square. This is equal to root of 50 square plus the difference over here comes out to be 125.27 the whole square. This is equal to 50 ka square is 2500 and 125.27 ka square will come out to be 15692.6. This is equal to under root 18192.6, and finally we will get Z ka value equal to 134.88 ohm. IRMS is equal to ERMS by Z over here. This is equal to 110 divided by 134.88. After solving this by log, we will get this as 0.8155, or we can write this as 0.816 ampere. Hope you all understood this. Let us check out the next sum. Find the capacity of a capacitor which when put in series with a 10 ohm resistor makes the power factor equal to 0.5. Assume an 80 volt 100 Hz AC supply. So we got power factor which is cos phi. This is given by the formula R by Z. Now this value is equal to 0.5 and we know that resistance ka value is 10 over here. So what we can write is 10 upon Z. This is equal to 0.5, or we can rearrange this to get Z upon 0.5. 0.5 is nothing but 1 by 2. So 2 par jaake we will get 20 ohm. Now in this circuit we have only resistors and capacitor. So Z is given by the formula under root R square plus XC ka square. There is no XL. So we can write this as Z square equal to R square plus XC square, or XC square is equal to Z square minus R square. Let us put the values. Z is 20 ka square, R is 10 ka square. This is equal to 400 minus 100, which is 300. So we can write Xc square is equal to 300, or we can have Xc is equal to under root 300, or we can write this as 100 into 3. So we will have Xc is equal to 10 root 3 ohm. Now to find the capacitor value, we will use the formula of Xc is equal to 1 upon 2 pi Fc. C is equal to 1 upon 2 pi F into Xc. Let us put the values. 1 upon 2 into 3.142. Frequency is given as 100. Xc is 10 root 3. So we can multiply this. We will have 6.284 into root 3 into 10 raised to minus 3, which will go above and become 10 raised to 3. Now we need to use log over here, and the final answer that we get is 9.2 into 10 raised to minus 5 farad, or you can write it as 92 microfarad. Hope you all understood this. Let us check out the next sum. Find the time required for a 50 Hz alternating current to change its value from 0 to RMS value. So frequency is given as 50 Hz and the value of current is becoming equal to RMS value, and RMS value is nothing but I0 by root 2, where I0 is the peak value. Let us write down the instantaneous equation of current. I equal to I0 sine of 2 pi F into T. We have to find the time when current becomes I0 by root 2, which is IRMS. So I0 by root 2, this is equal to I0 sine of 2 into pi into frequency is 50 into time. This I0 and I0 will cancel out. We are left with sine of 100 pi t. This is equal to 1 upon root 2. Now for which angle we have sine ka value as 1 by root 2. So it is sine of 45 or pi by 4. So we can write sine of 100 pi t over here. This is nothing but equal to sine of pi by 4, which gives us the value of 1 by root 2. So we can simply say over here that 100 pi t is equal to pi by 4. Let us cancel out pi over here, and what we get is t is equal to 1 by 4 into 100. So time is 1 by 400 seconds over here. We can write this as 1 upon 4 into 10 raised to minus 2. 1 upon 4 can be written as 0.25 into 10 raised to minus 2, or we can write it as 2.5 into 10 raised to minus 3 second time, or we can write it as 2.5 millisecond. Hope you all understood this. Let us check out the next MCQ. Calculate the value of capacity in picofarad which will make 101.4 microhenry inductance to oscillate with frequency of 1 megahertz. The frequency of oscillation is given by the formula 1 upon 2 pi root of L into C. If we take square on both the sides, we will have 1 upon 4 pi square LC. We are supposed to find the value of C. So let us take it on the one side. So we are left with 4 pi square L into F square. Let us put all the values over here. 3.142 ka square into L is given as 101.4 microhenry. Micro is 10 raised to minus 3 into frequency over here is 1 megahertz. Megahertz is 10 raised to 6, and we have to take square of this. So what we are left with is 4 into 3.142 ka square into 101.4 into 10 raised to 9. If we take it above, it will become minus 9. And by solving the remaining things by using log, once again we cannot skip it. We have to use log. If you have any query of how to use logbook, please click on the top right eye icon to check out the video that we have made on how to use logbook for solving sums like this. Once we solve this, we will get the answer to be around 249.7 picofarad. Pico is 10 raised to minus 12. Hope you all understood this. Let us check out the next sum. A 10 microfarad capacitor is charged to a 25 volt of potential. The battery is disconnected and a pure 100 millihenry coil is connected across the capacitor so that LC oscillations are set up. Calculate the maximum current in the coil. Now in this scenario, when you connect a capacitor along with an inductor, since the capacitor is charged, the energy of the capacitor, which is given by the formula half CV square, flows into the inductor, and the energy in the inductor is given by the formula half Li square. And then this energy again flows back into the capacitor and it continues. From law of conservation of energy, we can say energy in capacitor is equal to energy in inductor. This is given by half CV square is equal to half Li square. Half and half will be cancelled. We are supposed to find current, so we will write it as I square equal to CV square by L, or we can write I is equal to root of CV square by L. Let us put the values over here. C is given as 10 microfarad, or you can write it as 10 raised to minus 6. Voltage is 25 ka square divided by inductor is given as 100 millihenry. Milli is 10 raised to minus 3. So in the numerator we'll have 10 raised to minus 5 into 25 ka square divided by 10 raised to minus 1. This will become 10 raised to minus 1. In the numerator will be 10 raised to plus 1. So we will have 10 raised to minus 4 into 25 ka square. Let us take the root over here. So we will have I equal to 25 into 10 raised to minus 2. So we can write current is equal to 0.25 ampere. Hope you all understood this. Let us check out the next MCQ. A 100 microfarad capacitor is charged with a 50 volt source supply. Then source supply is removed and the capacitor is connected across an inductance, as a result of which 5 ampere current flows through the inductance. Calculate the value of the inductance. So once again over here we'll be using the same law of energy of conservation जो हमने last sum में use किया था, where we said that energy that is stored in capacitor is equal to energy that will be there in inductor, and energy in capacitor is given by the formula half CV square. It is stored in the form of electric field. In the inductor it is stored in the form of magnetic field, which is given by the formula half Li square. We want to find L ka value over here, so L is equal to CV square by I square. Let us put the values. Capacitance is 100 micro is 10 raised to minus 6. Voltage is given as 50. We have to take square of it. Current is given as 5 ampere, uska bhi square. So this is equal to 10 raised to minus 4 into 50 ka square will become 2500 divided by 25. So this will be 100 and we got 10 raised to minus 2. Inductor ka value is 10 raised to minus 2, or we can write it as L is equal to 0.01 Henry. Hope you all understood this. Thank you for your time. If you are finding this lecture series useful, then show us your appreciation by clicking on the like button, and don't forget to share it with your friends and classmates. And as you know, based on your feedback and suggestions, we'll be covering key concepts under our 5 minutes lecture series of class 12. So please feel free to let us know the topic you want us to cover. See you all in the next class. This is Professor Sandeep from Physics HQ signing off.